Hello participants, in this video I'm going to explain about the project theme, cross-cutting concepts. To join the project you may need some explanation about the concepts. This video mainly explains about the cross-cutting concepts and gives some examples in the real world or the learning context. Also, I'll give you some explanation what this project is going to reveal. Let's start from defining cross-cutting concepts. Cross-cutting concepts are some common themes located in many disciplinary contents, and scientists or students operate those concepts in their inquiries. I put a general term operate here, but it can be replaced with a specific student activities. The cross-cutting concepts are these 7 in the next generation science standards in the United States. These are the major cross-cutting concepts, but in the history, there are more concepts can be seen as a cross-cutting concepts. So you don't have to limit the cross-cutting concept within these 7. These are the list. We need an arrangement though. More than 100 concepts are expected as cross-cutting concepts. You don't have to know all these concepts because most of them are related to the represented 7 in the NGSS. They are embedded in each STEM discipline and related to all the learning within and across those disciplines. Next, you may need an answer to the question why we need to deal with those cross-cutting concepts. Answer is simply to understand your student's work in inquiry, to support a non-inquiry of the student, and to create a possible activity for learning inquiries. All of those are related to the teacher's work of assessment. We cannot assess the student work without understanding and supporting the work in learning. The premise is that both students and teachers are in a confused world in their inquiry activities, if they are rarely in the student-centered activities. Here is a kind of paradox that, although we need to define exactly what we teach for the class preparation and standard alignment, student-centered learning comes from student interest, not from preparation of that discipline. Therefore, we sometimes go into a chaos and cannot overcome the confusion. Our suggestion to this situation is putting cross-cutting concepts down the process of inquiry. Further, we can state that students process cross-cutting concepts in their activities. This means that we can support and assess student work on the way to cross-cutting concepts and the process itself, as well as the learning of cross-cutting concepts. Also, we can create a new activities based on the understanding of the processes and the targeted cross-cutting concepts. When this work will be completed, you can be aware of the cross-cutting concept will be the milestone to support your student inquiry, and the process will be a guided inquiry. Okay, let us take a look at the examples. Those are the exemplary view of the world through cross-cutting concepts. Pattern is the first example. You can see patterns in numeracy, in nature, and or in the recorded data. These are the objects of student observation, recognition, or awareness. Also, the patterns can be found in the society. For example, our communication has a pattern that subjects always affect someone by doing something. This is also one of the patterns we can see in the world. Students can learn the patterns from everyday communication to the application process in the city office. Next cross-cutting concept is the scale, proportion, and quantity. This is the basis of science, and it varies from very small scales, like nanoparticles, to huge scales, like the solar system or the universe. Students learn how each phenomenon happened in the different scales and how they are related. Also, they learn that some principles in certain scale may not be applicable to the other scales. For example, time we experience is not the matter in the scale of the universe. It is too short in the life of cosmos. Conversely, such a long time does not mean anything in our lives. This cross-cutting concept relates to the student work on measurement and the properties represented by the units. They are the symbol of scales, and sometimes represent the proportion of their components. The next cross-cutting concept is system and its models. System consists of some parts interacting with each other, and the parts also have input and output with each other. You cannot understand the system directly because they are sometimes too huge and too small. So instead, we have developed models and studied them. Nowadays, artificial intelligence, AI, is one of these models of human thoughts. Likewise, the models of the ecosystem, model of the atom, models of the human body are used to understand their function, behavior, or to test irreversible phenomena. The example can be found even in primary school, and such a mental model of system is developed throughout the curriculum. Next, we look at the cross-cutting concept, structure, and function. As you can see, these crystals have certain structures, and this is because of these structures at the atomic level. Their function as molecules is also determined by the structures, although the learning is too much for the primary levels. Similarly, you can find structures in systems, and these are easy to understand at the primary or secondary level. Let's look at the example of the chloroplast. The parts construct certain structures, and that's why they have certain functions. Photosynthesis. If chloroplasts have a function, it is to receive and produce certain substances. These substances cannot be replaced by the other substances. This means that the relationships between the parts of the system and the inputs and or outputs are determined. We can call this structure when the relationship becomes a prescribed phenomenon. Similarly, learning can be a promised phenomenon that has these structures. The learner receives information by a visible stuff or hearing something from the environment, and memories or processes are identified as a result. In this case, too, only selected information can be learned, and the others are ignored. There are a certain number of people watching the same video. However, each of you will learn different things from the content for sure. Also, this understanding can be applied to social studies learning. For example, when you go to the city hall and try to get a passport, you need an application form and processing fees. As a result, they issue you a passport and a record of the government. They will only receive a decided application form and decided amount of fees. Also, the product passport and record have a decided form. We should call this a structure, and because of this structure, the applicant and even the government workers can process these functions properly. Next, energy and matter come here. We can find different forms of energy in our lives and can see that they are conserved when they change into the other forms. Students can learn about transition from potential energy to kinetic energy, from chemical energy to thermal energy, and from magnetic electric energy to light energy. We can also find the energy transfer in the ecosystem or food web. They are all supported by the light energy from sunlight. Then the energy produced flows around the system as their food, including something for humans. We consume much more energy as a higher level predator. Next, cross-cutting concept stability and change can also be seen as a system characteristics. For example, a system river can change its appearance because of its input, rain. If the input increases, the river will look like the picture below light. On the other hand, flow remains the same river even though it is changing every moment. So you can see the concept of stability in the changing whole. This understanding can also be applied to the traffic in the social system. The train system can be thought of as a flowing river or people as a water. The more people try to get on, the more system gets busy. The flow changes every moment in the stable whole. The understanding of stability and change can be applied as an abstract style to the locking ship or to price setting in changing supply and demand. you can see the change in the stable system. Finally, the cause and effect could be found. The cause of the heavy rain on the river, the accident on the transport system, the big wave on the ship, or the radical political change on the supply will have some effect on the system, as the flood, the traffic jam, and locking of the ship, or the strong demand for certain goods. Although it is so difficult to identify a cause in the system, students can learn about the possibility of cause and effect. Students are also expected to learn the difference between the cause and effect relationship and the correlation. Identifying a difference may be beyond the scope of primary or secondary level education, but they can be made aware of the difference in a simple way. Okay, that's an explanation for the 7 cross-cutting concepts. Okay, let me explain the project and what we seek here again. As you saw, the cross-cutting concepts are common themes located in the many disciplinary contents, and the scientists or students operate those concepts in their inquiries. For example, scientists can find patterns in the nature, then also they moderate structure and function in their inquiry. In the STEM-related inquiries, how do scientists or students operate those concepts in their activities? This is the main question this project pursues, and we would like to ask you to contribute. As you saw in the explanation of the cross-cutting concept, patterns, there is a pattern of communication which has SVO style. The subject affects the object by doing something. This is a normal pattern of human behavior. When we translate this pattern in the context of inquiry related to the cross-cutting concept, student affects the object cross-cutting concept by doing something. This is a pattern of communication in the STEM-related inquiry. Thus, the purpose of this project can be understood like this. In the STEM-related inquiry, the student operate cross-cutting concepts. Therefore, we would like to know how students operate cross-cutting concepts. We need to investigate the verb must describe the student operation of cross-cutting concepts. We've already had theoretical example of these verbs in hand, so we would ask you to put more real examples from your experiences as a teacher and a scientist. Okay, that's it for this video. You can proceed to the task description video when it will be shared. The video will be sent to the person who submits the consent form. So if you like to join this project, please send the consent form first and wait for the next contact. Thank you for your participation, and we are looking forward to seeing your response. Thank you.